Hi guys, in this video we're going to have an introduction to scripting in HISE. This introduction isn't aimed at complete beginners, it's going to be quite fast paced and it's more intended for those of you who are familiar with scripting in things like Contact or if you've done some programming before. And it's going to be a sort of quick start scripting guide. In future videos I'll go into the individual concepts that I cover here in more detail. So the first thing we're going to look at is callbacks. Callbacks are a way we can respond to various events that might happen in your project. So for example, if a MIDI note is received by the plugin that you've created, that's an event and we can react to it. If a user interacts with a control on the interface, that's an event and we can react to that. So a callback is just a way of reacting to some kind of event, and it gives us a place to put code that will be triggered when that event occurs. So I've just got a blank instrument here. There's nothing in other than this interface script. And the first thing you'll notice, yours might look a little different to mine. You might only have one of these tabs. Don't worry about that. But the first thing you'll notice is we have this onInit callback here. So onInit is the callback that's triggered when the plugin initializes, or when you first load the plugin, or when you hit compile. That also runs the onInit callback. And if we click this menu here, we can see the other callbacks that are available, and we're going to go through each one of those. So these are all the basic default callbacks. There are some other custom callbacks which we'll look at later on. So we're just going to look at these ones for now. So like I say, onInit, that's triggered when we load the plugin for the first time, or when we hit the compile button, or press F5, that also triggers compile. So let's just demonstrate that. And we're just going to right click in here and clear the console, and up in the code editor, type in console.print hello world, and I'm going to hit F5. So that's going to trigger the onInit callback where I've written this code. And you can see down here in the console it prints hello world. I've just increased the font size of the code editor there. So that's the onInit callback, pretty simple. And init, of course, it stands for initialize. So now we'll go to the onNoteOn callback. This is triggered whenever an incoming MIDI on message is received. So if I press a key on my MIDI keyboard, that will trigger an onNoteOn callback. So again, I'm just going to type something in here. So when I hit a note, it's going to say hello note on. So I've hit F5 and I'm going to play a note, and now down in the console it says hello note on. And every time I press a key, it adds another line to the console. So let's clear that out now. The next one we have is onNote off. And this is pretty much the same as onNote on, except it happens when a MIDI note off message is received. So that's when you lift a key on the keyboard, for example. So I'm going to press a key down now, and nothing appears in the console, and now I'm going to lift my finger, and the text appears there. So that's the note off callback. Now we'll go to the onController callback. So this one is triggered when a MIDI controller message is received. So for example, if you move the mod wheel or move your expression pedal or any other CC, it will trigger this callback. So now I'm going to move my mod wheel, and you can see the text appearing there in the console. I'll just clear that out. I'm going to move my expression pedal. The next one is on timer. We're going to come back to that in just a moment. First we'll go to the on control callback. So on control is triggered when a user interacts with a control on the interface. So if we add a button to the interface and the user clicks that button, it will trigger the onControl callback. This callback is also triggered when you first open the plugin or when you hit compile, just like the onInit callback, and it's triggered after the onInit completes. So it'll run through all the code in onInit, and then it'll run through all the code in onControl, assuming you have some controls on your interface. If you don't have any controls, this callback isn't going to do anything. Now, one thing that's different about this callback is you can see we have this thing called number and this other thing called value. So number refers to the control that triggered the callback. I don't know why it's called number and not something more logical like control, but there it is, it's called number. So if I click this button, number is going to be a reference to the button, and value is going to be the value of the button. So if the button's on, it'll be 1, and if the button's off, it'll be 0. So let's just demonstrate that. So first of all, I'll do console.print number, and this is just going to print some object. There we go. Print some object name, which is an internal reference to this button, so it doesn't really mean anything to us, and every time I click the button it's going to add another line for that because it's triggering this callback. And when I hit compile, it shows it there as well because, as I say, this callback is also triggered after onInit. So now let's print out the value of the button instead. I'm going to hit F5 and the value is 0 because the button's off, and then if I click the button it now shows 1, turn it off again, shows 0. If I add another button to the interface, so I'll just duplicate this one, and if I hit compile it's going to show the value for both buttons. It's going to go through each one. There we go, 0, 0. But now when I click one of these buttons it's only going to show the value for that button that was clicked. So it just outputs one line each time there. Now this onControl callback is a kind of holdover from older versions of HISE. You're probably not going to use it much in your projects, but there are times when you will use it. There's better ways now of handling user interaction with the interface, but it's good to know about it, and as I say, it will come in handy sometimes, especially for simpler scripts. Okay, now let's go back to that onTimer callback. So the timer callback isn't triggered by a user interacting with your instrument directly. It triggers on a set interval, so you can say every second do a certain task, or every 10 seconds do a certain task. And that's pretty much what it's for, and it's useful for all kinds of things. One common application is animation. If you want to animate something on the screen, you can change the animation frame with this callback. So we'll just do a simple example. We'll output some text to the console at a given interval. Now I'm going to hit F5 and nothing's going to happen. Well, it says it compiled okay, but it's not printing the text every second or whatever. What we need to do now is start the timer running, and we need to tell it the interval that we want it to use. So we're going to do that in onInit, but you can do this in other callbacks. So if you want to start the timer using buttons, you could use the onControl callback, or if you wanted to start the timer when a key is pressed on the keyboard, you could use the onNoteOn callback. So to start the timer running, we're going to do synth.startTimer, and then inside these parentheses we give it the time interval we want in seconds. If you want milliseconds, just divide it by 1,000. So for 1 second, we'd put that. For 1 millisecond, we'd put this. So we're going to have it running at 1 second. And now if I hit F5, you're going to see it start to write out the lines from our onTimer callback. So once a second, it's going to print a line. So that's running nicely. Now we haven't put in a way to stop the timer, so let's do that now. We'll go to the onNoteOn callback, and we can do synth.stopTimer. I'm going to hit F5. So I'll clear the console and I'll hit compile. Now when I hit compile, it's going to start the timer running again because we still have that in onInit. So there we go, the timer's running. Now I can hit any key on my keyboard and it's going to trigger the synth.stopTimer function, and that will stop the timer running. So there, I've just hit it and no more lines are being printed. Okay, so that's all the basic callbacks covered. There are other callbacks that are more customizable and we'll look at those later on, but those are the basics and they will get you most of the way there with your projects. Okay, now let's look at variables. So variables are little spaces in memory where we can store values. So if we wanted to store the number 1, we can assign it a space in the computer's memory, and we can give it a little label, a little name we can refer to it as, and then we can put in our value. And then whenever we want to get that value back, we can just use the name or the label that we've assigned to that bit of memory. So the most basic variable is the var. So we just type var, and then we give it a name. So I can call it my variable. And then we can give it a value. So we put equals, and we say it's 10. So now we've assigned the value of 10 to a block of memory, and we've given that bit of memory the name my variable. And you can call the variables pretty much anything you want as long as it doesn't use a keyword in the language, and it can't start with a number. So if I put a number at the beginning and hit F5, we'll get an error. So it can't start with a number. You can put underscores in it if you wish. You can capitalize letters as I've done here. So that's the most basic type of variable. And we can use it in our script like this. So if I did console.print and then just put my variable, it's going to hit this line of code, console.print, and it's going to say, okay, we've got to get a value, and the value is stored in the memory that has the label my variable assigned to it. So it's going to look in my variable and it's going to get the value 10. So I'm going to hit compile and we're going to see 10 appear. There we go. And we can change it if we want. So here I can change the value of my variable to 20. And we can print it again. So now when I hit compile, it's going to first of all set my variable to 10, and it'll print it out. It will see 10 in the console, and then it's going to change the value to 20 and print it again. So there it prints 10, and then it prints 20. So that works. Okay, the next type of variable is the constant variable. And we write that with const var. And usually if you're just going to assign a number to a constant, you'll usually give it the name. The name will be spelt all in uppercase so that when you see it later on in your code, you know it's a constant. So it'd be something like that. There are times if you're using a constant to refer to an interface control, for example, then you probably won't write it all in uppercase. You'll just give it the same name as the control. So again, we're going to have this variable const var. So the only difference is we've added the keyword const and a space before var. And we're giving it the name my constant, and we've assigned the value 10. And if I hit compile, we'll see that print out. So there we go, 10. Now the difference between a constant var and a normal var is you can't change the value of a constant. So that's, as the name implies, it is a constant value. So if we try and change it, we put my constant equals 20 and I hit compile, we're going to get an error. So it says here, can't assign to this expression because you can't change the value of a constant. Now this is good because it means when your plugin is compiled, HISE will go through the script and it will replace all the references to my constant with the actual value, which is really useful because it makes your script more efficient. So whenever you can, you should try and use constant vars. Okay, the next type of variable we're going to look at is the reg variable. So that's reg. So in HISE, when you declare a variable like a var, it adds that variable to a big long list of all the other variables. And then whenever you want to access it somewhere else in your code, HISE has to first of all look up that variable in the big long list. So that takes time and it's not that efficient, and we're dealing with real-time programming because you want your instruments to respond to the user input in real time. To avoid this looking up issue, HISE has a register of variables that are predefined and the memory blocks are pre-assigned so that it doesn't have to do all this looking up. It can just go straight to the bit of memory where your value is stored. And we declare these as reg variables. So reg variables are really efficient if you're doing real-time calculations. So if you need a value that's going to be used in the on-note on callback, for example, then you're probably best off using a reg variable. And usually you'd write your reg variable in lowercase or camel case because it's not going to be a constant. So we call it my reg. Let's call it that. And you can pretty much treat it like a normal variable. So we see the value 10 there, and I can change it to 20 and print that again. If I hit compile, we get 10 and then 20. So it works just like a normal variable. But if you're going to use it in onNoteOn, this is more efficient than a normal variable. Now the limitation is, because these are pre-assigned blocks of memory, you can only have 32 reg variables in your onInit callback. Now there's a blog post that Christoph Hart made when he added the reg variables to HISE, and I'll provide a link to that blog post along with this video so you can check it out and read all the details. And in that blog post, Christoph has put a whole list of best practices for HISE scripting, so you really should read it because it will help make your code more efficient if you follow the guidelines that are there. Okay, now we're going to look at some variables that are kind of variations on the var. So the first one we've got is the local variable. So you just type local and then you can put the name, and the same naming rules apply. And then we'll give it the value of 10 again, and we'll print it out. And I'll hit F5, and we get an error. Now it says here, we can't define a local variable outside of inline functions or callbacks. Now we're actually inside the onInit callback, but the onInit callback is quite special in that it kind of exists outside of all the other callbacks. So let's put this in onNote, for example. So I hit F5 and that works there. Now, I don't want to go into too much detail about functions yet, but you'll notice that onNoteOn is preceded by the word function. And we've got these two curly braces. So the curly braces, whenever you see these, they define what we call a code block, which is basically just a block of code. So anything within the curly braces is considered to be within that code block. And another word for a code block like this is scope. So we say this is the scope of these variables or whatever we've put inside the curly braces. And a local variable is only accessible within the scope it's declared. So this local variable only exists between these curly braces. So it can't be accessed in onNoteOff or in onControl. It can only be accessed within this. So it's local to these curly braces. So that's what local means. Usually when we define a variable in the onInit, it can be accessed anywhere in the script. So it has script-wide scope. But local means it has local scope to the curly braces that it's within. And we'll see this triggered when I press a key. It will declare this variable and it will print it out. So that's local variables. The last one we're going to look at, if I go back to onInit, is the global variable. The global, and then we give it a name. I'll say it equals 10. Now, I'm going to hit F5 and it compiles just fine. So global doesn't mean global within our script. We already have those just by declaring a normal variable inside onInit. Global means you can have inter-script communication. So if we add another script and inside this script we print the value of my global and hit F5, it's going to print it here. So you can see it's printing from script processor 1, which is this one. So even though the variable was declared and set in this script, the interface script, we can access the value in another script. So although we've given it the name myGlobal, in practice you're not going to give your variables names like that link to their scope necessarily. You'd probably call this something like current articulation or last note or something like that, note ID. So when that happens, it can be a bit messy to keep track of which variables are global. Now, this way of defining a global variable is okay, but what it's actually doing behind the scenes is it's doing this, globals.myGlobal equals 10. And this is kind of hidden from you with this, but basically HISE has a big table of all the global variables, and every single script in your project can access that table of global variables. And it's called globals, and you put a dot and then the name of the variable you want to refer to it. So if we delete this line, for example, and I hit compile here, and then I go to the other script and hit compile, we're still going to get the text 10. So to make it clear that a variable is global, whenever you refer to it, it's best to do it like this, globals dot, and then the name of the global variable. And that way, whenever you see it, you will know straight away that this is a global variable, and it just stops you getting confused, or stops other people getting confused when they're looking at your script, or you're looking at your script in the future and you're trying to maintain it and add updates. So we can also change the value of it in this second script. So we can change the value to 50, for example, and hit compile, and now it says 50. And of course, because it's global, it's also changed it here. So even though it says 10 here, if you now use that variable anywhere else, it's going to say 50, because we've set it to 50 here in this onInit callback. Okay, I'm going to delete this second script for now, and we'll just go back to our main interface script. Okay, so now let's talk about data types. So in variables, we can store different types of data, and HISE Script, which is based on JavaScript, has several different types of data we can use. So the first one is a number, and that's just as it sounds, it's a number, and that can include floating point numbers with a decimal point in there, or it can just be a solid integer without any decimal component. But HISE Script will just see either of those as a number. So we can do something like const var n equals 58, for example, and we can output that to the console. And I hit F5 and we can see it outputs the value 58, so that's just a number. Next we can have a string. So a string is just text. So if we do const var s for string, and we'll say hello world. Now text or strings must always be within quotation marks, and you can use single quotes or double quotes, it doesn't matter. I usually automatically go for the double quotes though. And what's handy in HISE is if you type a quotation mark, it will automatically add a second one and put the cursor between them, so you can just carry on typing. It's nice and helpful in that way. And again, we can use the variable and it will output the string to the console. So that's numbers and strings. Next we have Boolean values, or sometimes just called bools. And a Boolean value, we'll put B for Boolean, is just true or false, 1 or 0, but true or false is how we can write it. So if we put true there and I hit F5, you see it outputs 1 to the console. So true equals 1 and false equals 0. So I can put false and it comes out as 0. So it doesn't really matter which one you use, if you use the number 1 or 0, or if you use the designators true or false. Often it can be a bit more human readable if you use true or false rather than just 1 or 0. So the next two, I haven't really used them much in HISE Script, and I don't think you will either, but the first one is undefined. So if I put control var u, and I'll put equals undefined, and if I put u in here where we have console.print and I'll put u, we're going to actually get an error message. So it says API calls with an undefined parameter, and we literally have an undefined parameter because we've assigned it an undefined value. So basically undefined means there is no value. In fact, if I delete this equals undefined and I hit compile, we'll get exactly the same error because we haven't assigned a value to our variable. So it gives us the equivalent of undefined. Another one that is similar is null. And if I hit compile, we should get exactly the same error message. So I'm not too sure when you specifically want to use null or undefined, other than if you were using those values and setting them and then you were checking them later on to see if they were specifically set to undefined. But usually it's more useful to set an actual value. But yeah, so if you see this error message ever that says undefined parameter, it means whatever you're passing into your function call, in this case console.print, doesn't have a value assigned to it, so it'll be undefined. Okay, so those are the 5 basic types of data that we can store in HISE script. That's numbers, including floating point and integers, strings, which is just text, Boolean, which is true or false, and undefined and null. There are 2 other sort of hybrid data types. So the first one is an array. So let's define an array. And I'm doing all of these as constant variables, but you could easily do these as reg variables or local variables. But I'm just doing them all as const for these examples. So we have an array, and if I do that, that's how we declare an array. So an array allows us to store multiple values in a single variable. So instead of just being limited to storing a single value, we can store many values. And they can be of different types as well. So that it could be, you could have an array that's just numbers, or it could be a mixture of numbers and strings, or it could just be Boolean values. It can even hold other arrays. So let's just have a look at this. So we've got the square brackets that indicates an array. And in here we'll put a value, we'll just put a number. And if we want to add a second value, we can put a comma. And I'll put a space as well, but you don't have to worry about the space. I just put it in there for readability. And then we can put in a second value and another comma, and we can put in a different value. We'll put a string in there and another comma, and there's another value. So we've got 1, 2, 3, 4 values in this single variable. So that's what we can use arrays for. Now, to access the values in our array, we can refer to the index of the array. So what do I mean by index? Well, if I type A and then I put the square brackets after it, I can put a number in here. So let's put 0, and that gives us the value 1, 2, 3, which is our first value in the array. So an array always starts at 0. The first value you have in your array will have an index of 0. And then the second value will have an index of 1. So if I hit compile, we'll see the next value output down here, 4, 5, 6. The next value in the array has an index of 2. So we've got some text output here. And then the fourth one will have an index of 3. So false equals 0. So that's really the sort of simple version of arrays. They can get more complicated if you include other arrays inside arrays. And we'll have a look at that now. So I'll add another comma, and now I'm just going to put an array inside this array. We don't need to declare it as a separate variable because it's being stored within the same one. It's being stored within A. So I'm just going to put 2 square brackets, and now we have a brand new array inside the existing array. And I can give this some values as well. So we've got 3 values in there now. So we've now got 5 values inside our A variable. And each of these values are referred to as elements. So we can say this array has 5 elements. And the 5th element is an array itself. And we can refer to that here with the number 4. So an index of 4. But if I hit compile, we'll get something interesting in the console. So you can see it doesn't give us any values. It just says it's an array. So if we want to refer to one of the values within this array that's within our other array, we have to refer to them by this array's index. So we'll put some more square brackets, and we can put 0, and that will give us the value of 7. And we can put 1, and that will give us the value of 8. So this is a slightly more complicated example, and when you have arrays inside arrays, these are referred to as multi-dimensional arrays. If we go up here and click on this button, we can see the script watch table, and this shows us all our variables. And if I right click on this one that's got the name A, so that's referring to this variable we're dealing with, if I right click on that, we can actually see the whole array structure laid out in a more easy to read form. So we can see that this array here is within this outer array. Okay, let's look at something else with arrays. So I'm just going to delete what we've got here, and let's just go back to having a blank array. And I'm just going to put some simple values in here. We'll have 1, 2, and 3. Now, if you want to add a value to this array later on in your script after you've declared it, so it might be in a completely different part of the script, you want to add a new value. There are 2 ways to do it. So you can type A, and then you can put the index. So we've got 3 values here. So we've got 0, 1, and 2. Those are our indexes. So the next index will be 3. So we can say 3, and we can say equals 57. And now if I hit compile, and we can go back up to here and look at our array, we can see that the value 57 has been added to the end of the array. But let's say we didn't want to add it to the end of the array, we just wanted to replace one of these existing values. So let's say we wanted to replace 2 with 57. We can just change the index, and the number 2 is the second element in our array, so that means it has an index of 1. So if I hit compile again and we look at the array, we can see now that the number 2 has been replaced with value 57. So you don't have to declare all the values in your arrays up front. If you don't know what they are, you can do it later on in your script as they're required. So you can also have a completely empty array, a declaration, and then you can just add values to the array as you need them throughout your script. So here we've got an array that's empty, and we're adding the value 57 to index 1. Now remember, index 1 is the second element in the array. So we haven't added anything for index 0. So watch what happens. I'm going to hit compile. And if we right click on the array, we can see that it's automatically added an empty value, an undefined value for index 0. And it's put our value 57 at index 1 as we want. So it's just something to be aware of, that an array will always have values starting. So it's just something to be aware of, that an array will always have values starting from index 0. Even if you don't put anything in at index 0, a value will be added automatically. In this case, it's undefined, so it's like a non-value as such. But if you get any weird errors, saying with undefined parameters, and you're referring to elements in your arrays, just check that they haven't been set to undefined. So another way we can add values to an array, let's say we want to add a value at the end of an array. So let's just populate this again. So to add a value to the end of this array, we can do what we did before and type A, and then the next index, which will be 3, and then put the value in there that we want. But let's say we don't know how many elements are already in the array, we just want to add a value to the end. Instead, we can use a command called push. So we can put the name of our array, in this case it's A, we write dot push, and then we can just put a value in here that we want to add to the end. I'll put 78 in there, I'm going to hit F5, and it will have added that value onto the end of the array. So that can be quite handy sometimes. You'll probably find yourself using that little command quite often. Okay, so the next data type we're going to look at is called an object. And objects are quite a powerful concept in HISE Script, but we're just going to deal with them in quite a simplistic way first of all. So this is how we declare an object. So it's very similar to declaring an array, except we use the curly braces instead of the square braces. Whereas in an array we assign values and the index is assigned from 0 automatically, with an object we have to designate the index. And the index is referred to as a key, and the value that we assign to the index is referred to as a value, and we call that together a key-value pair. Now the index can't be a number, but it can be a number as a string. So for example, you couldn't put 0, but you could put 0 in quotation marks, and that would work just fine as a key. And then after that you have to put a colon, and then you put the value you want to assign to that key. So we'll just put 1, 2, 3. So that's a key-value pair. So the key or index is 0, and the value it has is 123, or 123 in this case. We could also use a text value for our key, and we don't necessarily have to put it in quotation marks. We only have to do that if it's a number like we had there. So we could just put K, for example, and our value could be a text string. Now I'm going to hit F5 and we can see what's stored in our object here. And you can see it automatically places the quotation marks around the K index that we've assigned. So that's why we didn't need to include it when we were declaring our object. So that's the basics of objects that just hold key value pairs, but they can get much more complicated. And the values that you assign to them, like an array, it can be numbers, it can be strings, it can be booleans, it can be arrays, or it can be other objects. Now if you want to get a value from the object, we have two ways of doing this. So let's go to console.print and we'll put our object in there. Now the first way to do it is exactly what we do with arrays. We just put the square brackets and then put our key in there. So I've put the key K in there, so when I hit compile it should print the value text to the console. So that appears down there. So that's the first way of doing it, just like we do with an array, and sometimes you'll want to do it this way. And the other way of doing it is to just put a dot, so a full stop or a period, and then put the key. So we could put the K there. And now if I hit F5, it prints out text down here. Now our first key that we used is a 0. Let's see what happens if I just put 0 here. We get an error because it doesn't know that 0 is a string in our object. It thinks we're just referring to a number, and if I put it in quotation marks, that's not going to work either. So this is an example of when you'd want to use the square bracket method. So those are two different methods, and which one you choose will depend on what keys you're using and also the situations in which you're using objects. And the situations where you'd use either of those are going to vary greatly depending on what you're doing in your particular script. As we go through other videos, you'll see me using objects and accessing them in both ways. Now, just like with arrays, we can assign new values to the object after we've declared it. And again, we can do that in the same sort of way we did with an array. So we could do something like that to change the value of our K key. And I'll just hit compile there. You'll notice I've also changed the data type, because before the key K was holding a value that's a string, and now I've changed it to hold a number. And if I right click over here, we can see that it has updated and it's holding a number quite happily now. So you can change the data type. The data type is dynamic. We could also get K to hold an array, for example. So there's nothing wrong with storing arrays inside an object. There we go, we've got an array inside there. So we could even store another object in this object. So let's do that quickly to have a look what that looks like. I'll just give it one key value pair. We'll give it the key P, and we'll give it the value of 12. I'll hit F5 and we'll just see what that looks like. So there we have another object inside our main object. So very similar to what we did with arrays. And if we want to access that, we can do something like this. We could do O, which is the name of our variable. And then we can either use the square bracket method, or we can just use the dot method. So do dot K. So that's now referring to this value, which we've obviously replaced here with an object. And then within this object, we want to refer to P. So we can do dot P. And now when I hit F5, it should print out the value 12. There we go, 12. And like I said, we could do this with the square brackets if you prefer. And that works exactly the same. And like I said, which method you choose will depend on what your specific needs are within your script. So that's a very, very mild overview of objects. They can be used in much more complicated ways. And in HISE Script and JavaScript, objects are a fundamental component. And in fact, things like arrays are actually a type of object. But we don't need to worry about that kind of thing now. And in fact, most of the time when we're scripting, we don't really need to worry about that. We can just think of objects as a way to organize data. So what we're going to look at now is operators. It's easier for me to just show you than to explain what they are. You'll soon pick it up, I'm sure. So we have three types of operators. We're going to look at mathematical operators first. And mathematical operators are things you're familiar with. It's like addition, subtraction, division. And we're just going to have a quick look at what we've got available. So we'll have, let's make two variables. We'll have A, and we'll give it a value of 10. And we'll have B, and we'll give it a value of 5. And actually we'll have another variable where we'll do our calculations. We'll have C. And this is going to equal something. We'll look at that in a moment. And we're always going to output C to the console so that we can see the result. Okay. So our first one is addition. So if you want to add two numbers together, you can either just write it out, so 10 plus 5, or you can use variables like we've got here. So we'll do A plus B. And if I hit F5, we see the value 15 is output. Okay, now we'll have subtraction, exactly the same sort of thing. I press F5 and we get 5 down there. If I swap these over, if I swap B and A over, we're going to get a negative number. We get negative 5 because we're now doing 5 minus 10. So the order of operation is from left to right. So it's going to be B minus A in this case. Okay, the next one is multiplication, and that uses an asterisk. And I'll hit F5, we'll get the value of 50. So that's 10 times 5 is 50. Then we have division, so we'll do 10 divided by 5, A divided by B, and we get 2. The next one is the modulus one, or modulo, which is a percent sign. And if I hit F5, we're going to get the value 0. Now what this does is it does a division and it returns the remainder. So we're doing, so 5 divided by 10 doesn't have a remainder because it's just 2. So if we change this to something like 3, so now it's going to be 10 divided by 3. Did I say 5 divided by 10? I meant 10 divided by 5. Anyway, we're doing 10 divided by 3 now. So we're going to have a remainder because 10 doesn't divide into 3. And the remainder we get is 1. So that's what the modulo does, or modulo. That's what it does. It gives us the remainder, and that's very useful in certain circumstances. Okay, the next one we're going to look at is called the increment operator. So that's a bit different to these sort of normal mathematical operators. So I'm going to create a new variable, and I'm going to call the variable D, and I'm going to give it the value of 7. Now you'll notice this isn't a constant variable, and that's because we're going to change the value. So we're going to write D plus plus. Plus plus is the increment operator, and increment means add 1. So plus plus is going to add 1 to D. So when I hit F5, we're going to see it print the value of D, which is going to be 7 plus 1, so 8. So there it is, value 8. And to go along with that, we have the decrement operator, which reduces the value by 1. And that's just minus minus. And I hit F5, and we get the value 6. So that's how the increment and decrement operators work. Now, one more thing I'd like to show you with the mathematical operators is the use of parentheses. So let's say we've got A times B. So we know that's going to be 30. But let's say we don't want B to be 3, we want B to be 5, so we add 2 to B. So now we're doing 10 times 5, we hit F5. But no, it doesn't give us the value 50, it gives us 32, because what it's actually doing is 10 times 3, which is 30, and then it's adding 2, because in maths, multiplication has precedence over addition. So this is known as BODMAS or BIDMAS, or it has a few other names. But basically, sums are read left to right, and multiplication has precedence over an addition. So that means multiplication is treated as is calculated first, and then the addition is done separately. But if you want the addition done first, or you want something else done before the multiplication, then you need to put it in parentheses, because parentheses have precedence over everything else. So we can just do that like this. So now the sum reads as b, which is equal to 3, b plus 2, so this will be 5. So it's now a times 5. And if I hit compile, we get that result 50, which is what we'd expected. So that's pretty much all of the mathematical operators. There's one other thing I'd like to show you before I move on to the next type, and that is another use for the plus operator. So if you're working with strings, so let's create a string, we'll say hello, and let's say we have another string, call it S1, and this is going to be world. If you want to attach those strings together to say hello world, you can do that using the plus operator. So we do S plus S1 and hit compile. Let's just clear that out, hit compile, and it prints hello world. So in this case, the plus isn't being used for mathematical addition, it's being used for what's called concatenation, which is sticking two values together. And it doesn't just have to stick text together. If we actually change this and just we can use our a variable, for example, and hit F5, it now says hello 10. So you can use it to attach strings and numbers together, and as soon as you have a string in there, HISE will interpret that as concatenation rather than addition. So that's just really useful, and we'll be using that quite a bit as well in the future. Right, the next set of operators we're going to look at are called comparison operators, and these compare two values and tell you if it's true or false. Now remember from our look at data types, true or false are Boolean types, and they'll be equal to 1 for true and 0 for false. So the first comparison operator we're going to look at, let's just go down here a bit. We'll say const var, and we're going to have, what should we call this? Well, we've got A, B, C, we'll have D again. We had that earlier. And this is going to be where we're going to start our comparison, and we'll print that out to the console, D. So the comparison is things like are two values equal. So we can say is A equal to B, and the comparison for equality is two equal signs, one after another. So if I hit compile, we know that A is not equal to B, because A is 10 and B is 3, so we'll expect that to be false, so 0 is what should be printed to the console, and it prints 0. If I change B to equal 10 and hit compile, it will now get 1 on the console because A and B are equal. Okay, the next comparison operator we can do is the not equal to. So we've got A equals B. To get not equal to, we can replace the first equal sign with an exclamation mark. And now if I hit compile, we get the value 1, which means true. So that's saying A is not the same as B, which is correct, because A is 10 and B is 3. The next one we have is greater than. This is checking to see if A is greater than B, and if it is, it'll return 1, or true. So let's hit compile, and we get a 1. Because A is 10 and B is 3, A is greater than 3. And we also have the less than sign, which is like that. That's saying, is A less than B? No, it's not, so we get a 0 output down here. Then we have another one which is greater than or equal to. That's saying, is A the same as B or higher? And in this case, it's still higher, so it's going to say 1. But if we change B to be 10 and we hit compile, it's going to give us the 1 because it's got the equal to. But if we take away the equal to, it will say 0 because A is not higher than B. It's equal to B. So that's the greater than or equal to sign, and we also have the less than or equal to, which checks if A is less than or the same as B. Let's change B back to 3. So those are the basic comparison types. And like everything in HISE Script, we can use these in many different ways, and we'll see more examples of these as we go along in other videos. Okay, now we've actually got one more type of operator to look at, and these are called logical operators. But we can't really explore them without learning about another concept, so we're going to sort of learn about both at the same time. So the other concept is control statements. So that's allowing your script to make decisions. Now the most basic way to do that is what's called the if statement. So we can say if something, then do something else. So let's declare two variables. We'll have a, and again we'll do a equals 10, and we'll have b equals 5. So we're going to have this if statement, and we write that with the word if, and then we put some parentheses, and in here we put the thing we want to compare. So we're doing a comparison, and we can just do similar to what we did before. We can do a equals b, so we're saying if a equals b, and then we want it to do some action, so we put some curly parentheses to declare a new code block, some curly braces, and in here we can say what we want to happen if a equals b, and we're going to say output to the console true. Now we know that a doesn't equal b, so when I hit compile nothing's going to happen. So in order to handle something else, if this isn't true, we can use the else clause. And we just write it like this, else do this. And we'll print false. So we're saying if A and B are the same, print true. If they're not, else, print false. So I'll hit compile and it will print false. If I change it so A and B are the same and hit compile, it will print true. Now with this control statement, we can use all of the comparison operators we looked at before. So we can have if A is greater than B, if A is greater than or equal to, if it's less than, we have all of those. And then we have what are called logical operators. So logical operators check if values are true or false. That's individual values. So false is always 0, and true is anything that isn't 0. So usually it's 1, right? That's usually how we think of it. But when we're doing a comparison like this with logical operators, we've got to remember that anything that isn't 0 is considered true. So for example, our first logical operator is the AND operator, and we write that with 2 ampersands. So we're saying if A is true, that means it's not 0, and B is true, then print true. Okay, another way of writing this is saying if A does not equal 0 and B does not equal 0. Okay, that's essentially what's happening, but we don't need to bother with these bits because by default it's saying that anyway. So we'd expect, because neither of these values are 0, if we hit compile it's going to say true. Okay, we get true. If I change one of these to 0, like I'll change the B to 0, it's going to say false. Because it's saying, because now one of these values is 0, it is false. So for this overall statement to result in a true value, both of these must be true. Okay, now we can use this to check for specific values. So we can say if A equals 10 and B equals 3. Now we know that B equals 5. But let's say we wanted to check if A equals 10 and B equals 3. So I'll hit compile and it's going to print false because B equals 5. But that's a way to check for specific values. So I'll change that to 5 and now we'll get true when we hit compile. And because we've already looked at our comparison operators, we already know that what we're saying here is does A equals 10? That'll be a 1 because it does. And does B equals 5? And that'll be a 1 because it does. So we're saying, is it 1 and 1? Is it true overall? Okay, another logical operator we have is the OR operator. So this was AND. where both values on either side have to be true. The OR is like this, and only one of them has to be true. Both can be, but only one has to be. So it's, is this one 1 or this one 1? So if we change the b to equals 3, then b equals 5 is obviously not going to be true, but we're still going to get true printed down here because a equals 10 is true. So we get true there. If both of them are false, so let's change a to be 9, for example, then we'll get false. So with the OR operator, only one of the values has to be true. Okay, let's just simplify this again. Let's go back to our sort of default. So this currently checks if a and b are greater than 0, essentially. But let's say we didn't want that. Let's say we wanted to check if a and b were 0. So we could write it like this. But that's quite a bit of extra code, right? So we can do this in a simpler way. We can put this inside another set of parentheses. Okay, let's just separate that out. So our little check is now inside another set of parentheses, and before all of it, we can put an exclamation mark. Putting the exclamation mark flips this on its head, and it will do the opposite of what it usually does. So now it's printing false. Even though both these values are true, it's actually saying they're not true and printing the false. If I get rid of the exclamation mark, it'll print true. Okay, so the exclamation mark comes in handy quite a lot as a shorthand for just saying do the opposite. And the correct term for this operator is not. So our three logical operators are AND, that's the AND operator. We've got two pipes, which on my keyboard is the button next to the shift key, and you have to hold shift to get that symbol to appear. So this is the OR operator. And then we've got the exclamation mark, which is the NOT operator. And it's possible to mix these together. So let's have another variable. And we'll call this one C, and we'll give it the value of 50. And let's say we want to check if A is equal to 9 and B is equal to 3, or C is equal to 50. Now in this case, all of this is going to be true because A does equal 9, B does equal 3, and C equals 50. So we're going to get true printing out. I'll just delete that, otherwise we'll get an error. So we get true. Now again, we've got to think of these as units. So this is one unit that returns either a 1 or a 0, either true or false. This is another unit that returns either true or false. And this is another unit that returns either true or false. And again, we have an order of precedence going from left to right. So what this is saying is this unit 1 and this unit 1, or is this unit 1? And if these two are both 1, or this one on its own is 1, then we'll get to print true. So we can think of this as a sort of super unit where both have to be 1, and this one, if it is 1, because we've got the OR, that will overrule both of these and still be true. Now if you want to group them differently, let's say we want it to be if A equals 9, so that's a unit on its own, and B equals 3 or C equals 50. So this will be a separate unit. We can group them with parentheses. So we kind of switched it around. So now this is a single unit that must return 1 in order for this to proceed to the true statement. And, because we've got the AND here, this whole unit must return 1. And the subunit is the B and the C parts either side of this OR. So I'm hoping this is making some kind of sense because it's kind of hard to get your head around until you've played with it. So but what's going to happen? Well, let's click compile so we can see it comes back as true. So in order for it to be true, both sides of this AND operator must return a 1 ultimately. So is A equal to 9? Yes, it is. So that returns a 1. And then we've got this whole thing here where we've got an OR, so as long as either that or that return a 1, this whole unit will return 1. And in this case, B, does it equal 3? Yes, it does, so that returns a 1. And also C returns 50, so that also returns a 1. So these are all returning a 1, so we're going to get true. But if we change B to equal to 5, we're still going to print out true, even though B equals 3 returns a 0 because it's false. Because we've got this OR statement here, only one of these two have to return true. If I change the C value so it doesn't equal 50 anymore, then we'll get false. There we go, false. Because the statements on either side of this AND operator no longer both return a 1. So I hope this is making some kind of sense. It doesn't sound like it's making sense to me, but maybe it'll make sense to you. If you need more explanation on this, I can go into it in more detail and give more examples. And hopefully that information will get across to you. Play around with it. These logical operators need to be experienced to be really understood, and you'll see them in you'll use them in different contexts, and then you'll really get a feel for them. And you'll mess up a lot at first, and you won't know why, but you'll figure it out. It's just, you got to trust me. It's one of those things you need to use and experience to really get a grasp of. Okay, so I'm just going to simplify this. I'm just going to say if A equals 9, and we'll get rid of the C variable. So we've gone back to our simple little example. If statements are really useful, and you'll use them all the time, and inside these code blocks for each section of the if-else statement, you can put multiple lines, so you could have much more code in here, and you can even have other if statements in here. But in this simple example, we actually only have two things happening. We have if something is true, do one thing, otherwise do another thing. And we actually don't need to take up this much space to write that. We can write it all on one line using what's called the ternary operator. It's also called the conditional operator. But it's basically another way of writing a simple if-else statement. So I'm going to rewrite this all on one line. So we do A, does A equal 9? Then we use the ternary operator, which is a question mark. And if it does, we do our print true. Otherwise, and instead of writing else, we just put a colon. We do print false, and then we end it with a semicolon. So this is doing exactly the same as we had up here, but all on one line. So this is very useful when you've just got a simple if-else statement, and there's no need to write it on multiple lines. So again, this is just doing a check for 1, basically. It's saying, is A the same as 9? Is that true or false? Is it 1 or 0? And if it's 1, do this thing. If it's true, do this thing. And if it's false or 0, do this thing. So if I hit compile, we're going to expect to see true. And if I change A to equal 10, we should now expect it to print false. So that's the ternary operator or the conditional operator. Really useful for reducing the number of lines of code. Sometimes it can make the code a little harder to read. Sometimes it's easier to read. I quite like it. I use it quite often, but some people don't like it as much. So it's up to you whether you use this or you just use a standard if statement. Now there are some other operators. There's bitwise operators and there's the type of operator. We might cover those in other videos, but we're not going to look at them in this. All the main operators that you're ever going to use, we've covered. And with those operators, you'll be able to do pretty much everything you need with if statements. Okay, one other thing we can do with the if statement. Let's just, we'll write another variable. Another constant, we'll call it C. So we'll say if A equals 10, A is 10. So that's great if we want to check if A is 10, but let's say we want to see if A is 10 or if B is 5 or if C is 6, and we want to do different things for each one. Well, we have the else for saying if this is true or if it's not true, do something else. But we can also do else if. So now we'll put in here B equals 5. what we're saying here is, if A is 10, do this. If it isn't 10, check if B is 5. And if B is 5, do this. And we can go further. We can say, if B isn't 5, check if C is 6 or 7 or whatever value you want to check. And we can do something like that. So that's a way of checking 3 different values. And it ripples down. So it will only do this if this one isn't true. And it will only do is C equals 6 if this one and this one isn't true. And obviously if you want to check them all individually, you can just delete the else and have individual if statements like that. Now let's just go back to that. So this is great if you've only got like 3 values like we do here. But let's say we want to check, we want different conditions depending on the value of A. So let's say if A is equal to 8, we want to print, I don't know, let's do names or something. We'll have Bob, have Sarah, and we'll have John. Okay. So we'll say if A is 10, print Bob. If A is 8, print Sarah. If A is 6, print John. Now we know that A is equal to 10, so if I hit compile, it's going to print Bob. But if I change A to be 8, for example, and hit compile, it's going to print Sarah. And if I change it to be 6, it's going to print John. That's great, and we could keep this going for as many values as you want. And we could even have an else with nothing in it, like no if after it. And we can put a generic one in here. So if it's any other value, if it isn't 10, if it isn't 8, if it isn't 6, then it's going to go to this else and it's going to print Dave. So if I put 16 in here and hit compile, it prints Dave because Dave isn't covered by any of these other 3. So that's great if you've only got a few values to check. But you can see that for each one of these we're using quite a few lines of code and it's not so easy to read. So there's a better way of doing that. It's called the switch statement. So let's delete all of this and we'll rewrite this as a switch statement. So we write switch and then we put some parentheses, and in here we put the value we want to check, and it's going to be the value of A, so we just put A in there. Hit enter, put some curly braces, and we want to say if A equals 10, and rather than putting that if statement, we just write case 10 and a colon. So we're saying if A is 10, what do we want to do? We can write this on another line, tab it in, or write console.print Bob. And we finish a case statement with the word break and a semicolon, so this becomes like a little code block within the switch statement. And then we can write another case. So I forgot what the number was, but we'll put 6. Do console.print Sarah break, and one more 8. And instead of having a generic else, we use default. And we can do console.print Dave and change that to capital. So this is doing exactly the same as our if statement, except it's in a different format. So we're saying, does A equals 10? No, A is 16. So it doesn't equal 10, it doesn't equal 6, it doesn't equal 8. So it defaults to this line and it prints Dave. We change this to 10 and hit compile, it prints Bob. So it works exactly the same as the if statement. It's just great when you've got these multiple cases and it's a bit easier to read. Now there are different ways of sort of formatting this. Some people like to tab the break statement under the code block, under the case code block. If you've got a simple thing like this, you might put it all on one line. You might write each one out like that. And that's probably how I'd do it because I like to have fewer lines of code, but you can format it in different ways as long as all the components are there separated by colons and semicolons as needed. Now within a case you may even want to put an if statement. So let's have another variable. b equals 50. So let's say in this one we want to say if b is 20. Let's tab that in properly. Then console.print, I don't know, chicken. Else print John. So now I've got an if statement within our case for this, which is within the switch statement. So if I hit compile, it's still going to print, what's it going to print? It's going to print Bob. But if I change A to equal 8, it's going to print John. And if I change B to equal 20, it's going to print chicken. And you can put ifs inside ifs and switches inside switches inside ifs inside switches inside ifs, and you can just keep going on until your computer crashes. But try and keep it simple, it makes it easier to maintain. Alright, so the next conditional statement we're going to look at is the for loop. The for loop is just a way of doing something multiple times. So let's just write one out first of all, and then we'll go through it. Okay, so that's your basic for loop. So we start it off with the word for, because it's a for loop, and then we've got some parentheses. Now in these parentheses, we've got I equals 0. So what we're actually doing here is we're declaring a variable called I. And we don't have to write var, we just write the letter I, and HISE takes care of the rest. But that is a variable called I, and this variable only exists within our loop. So from this curly brace up to our for loop. So that's where it resides, that's its scope. And we're saying it equals 0, so we're going to go from 0 with our loop. That'll become clear in a moment. And then put a semicolon to sort of end this little bit. Then we're saying I is less than 10. So that's the value we're going to go to. So this bit overall basically says loop from 0 to 10. And then we've got I++, and you'll probably remember the increment operator. So this is saying add 1 each time we go around the loop. So we're going to go around the loop 10 times, because we're going to go from 0 to 9. And it's 9 because we've got the less than symbol. So we're going from 0 to 9. And our counter, which is I, is going to increase each time. So let's just output this and you'll see what I mean. So do console.print, and I'll just put I in there, and I'll hit F5, and you can see it outputs 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's looping 10 times, and each time it's outputting the value of I, and then the value of I gets increased by 1. Now we don't have to go from 0 to 10. We could go from 10 to 100, and it outputs that. We could go from 10 to 1. We could go down and would change, instead of having plus plus, would have minus minus. So we've got minus minus, then we've got to change this, instead of being a less than, we've got to change that to a greater than symbol. And we hit F5. So that's just doing the same thing but in reverse, so we're counting down from 10 to 2. And it'll never reach 1 because we've got the less than the greater than symbol, but if we change that to 0, it'll go down to 1. There we go. So that's the basics of a for loop, and I've just set it to go from 0 to 10 again. Now what you do in the for loop will vary greatly depending on what you're doing with your script and what functionality you want. Now inside here you may have if statements, you may have switch statements, you might do something mathematical using mathematical operators, you might output things to the interface. You shouldn't declare variables inside a for loop. If you want variables that you're going to access in your for loop, you should declare them outside the for loop. But you can basically do almost anything that we've looked at within the for loop. So a very common thing is working with arrays. So let's have an array called A, and we won't give it any values, but we're going to populate this array. We're going to give it some values. So we know that the array index always starts at 0. The first element has an index of 0, and it just so happens that in our loop we're going from 0 to 10. So we're going to use I as our index. So we're going to say A, and then I as the index equals, in this case we'll put I. And I've just realised that should be a less than symbol, so I'll just change that. There we go. And I'll hit compile. And now if we look at our array over here, we can see it's added the values 0 to 9 into the array. And this doesn't have to be, you don't have to use I here. You could put, I don't know, just some text, whatever you like here. And it will populate the array. And it's going to add 10 elements because we're going from 0 to 10. Now, as we've seen before, you can use the push command as well. You don't have to specify the index, so you could do push. And it's still going to do exactly the same thing and the same number of times because the loop is still going 0 to 10. We get the same result, and if I change that to I, we'll get 0 to 9 in there. So that's a really simple way of adding data to an array in a loop, and you can do the same thing for pulling values out of an array as well. So let's look at that. So if we add values to this array, I'm just going to add some numbers in kind of randomly. And if we want to output these to the console, do A and put I here. Now we're probably going to get an error. And let's hit F5. It's going to print some and then it's going to give us an error. Okay. So it prints out all the values in our array. But then you can see here it's given us an error API call with undefined parameter. And that's saying on line 18. No, it's not. It's saying on line 8, sorry, column 18. And this is line 8 and the undefined parameter is this. And basically the problem is we're going from index 0 to index 9. But our array only has 1, 2, 3, 4, 5, 6, 7, 8 elements. So it can't find the next one, which is why it's saying it's undefined. So the way we could solve that is to change this 10 for an 8, for example. I'll hit F5. And that works fine. But let's say you don't know how many elements you're going to have in your array. So this might change. You might add another one. But you don't have to update this every time. So a really easy solution to get the number of elements in an array is to write the name of the array, put a dot, and then write the word length. And length gives the number of elements in an array. So if I hit compile, let's play that. Let's hit compile and it prints everything out. And what I'll actually do, just so you can see this, is I'll do console.print a.length, and this will give us the number of elements in the array. So 9. So that's really handy to save you having to adjust a value here to get the length of the array every time you change the number of elements in the array. So another thing I find really useful when working with loops, and you'll see this in other videos I make, but we'll just do a simple example here, is string concatenation. So if I write some text, I'll write this is a number, and then we'll put the plus symbol, and then we'll put the variable I. Now, because we've got a string here, HISE is going to interpret this plus as concatenation and not maths. So it's not going to see this as a number, it's going to see it as a string. And if I hit compile, we get this is a number 0, 1, 2, 3, 4, 5, 6, all the way down to 9. So that's really handy, and you'll see me using that in a number of different ways. Okay, so that's the for loop. That's the basics covered. Again, you can kind of expand on this and do what you want with it, and it's got an infinite number of applications. Another variation on the for loop is the for in loop. Now this is used just with objects. So let's declare an object, call it O, and we'll give it a few key value pairs. So we'll have A10, B20, C30, that'll do. And then we write for, and then we put our parentheses, and we write, we have to declare a variable, So like we did with the other for loop where we had for I, in this case we're going to use the letter K for key because we're dealing with key value pairs. So for K, and then we put in, and then we put the name of the object. So ours is called O. And what this is saying is for each key, A, B, C, in object O, loop. So it's going to say go through each key. And then we can print this to the console. We can print each one. So we go print K. So it's going to go through the loop and it's going to get each key and print it out. So we've got A, B, C. And that's what we get down here, A, B, C. This time if I do O for the name of the object and do the square brackets and put K in there, so it's getting the key from the for in loop, we're going to get the value that goes with each key in the object. So instead of printing the keys, we're going to print the values. And we get 10, 20, 30. So that's a great way of working with objects using a for in loop. Now we're going to look at what is really the most basic loop in JavaScript, but I find I'm using the for loop so much more, which is why I showed you that first. We're going to look at the while loop. So the while loop, like the other two loops, will do something multiple times while an expression is true. So as long as whatever it is that we're checking is true, it will keep looping. So we'll say while and we give it some parentheses, and then we have a code block. So while whatever we put in here, whatever we put in there, as long as it equals 1 or true, this loop will continue to go. So we'll put console.print. I don't know what we're going to put in there yet, but we'll decide in a moment. Let's just have a simple counter. So we'll declare a variable. We'll call it count. We'll have it equal 0 to start with, and then we'll say in here while count is less than 20. And then down here we'll increment count each time we go through the loop. So this is just going to count up to 20. And no, it's not, because I've got an error. What's the error? Can't assign to this expression line 8. It can't be a constant variable because we're changing the value. Okay, there we go. So that counts from 0 to 19. Now this is quite similar to the for loop in its current version like this, but just imagine instead of having this count is less than 20, this could be referring to anything that can be compared. Okay, so I can't really think of another example right now that I can show you simply with a while loop, but it's one that I don't use that often. In fact, I very rarely use it. I usually find a for loop is more versatile and more useful, but sometimes I'll use it. So in other videos you may see me using a while loop, but this is the basic principle. It just says while this expression is true, do whatever you put in between these curly braces. Now obviously if this expression is always true, then the while loop's going to run forever. So you've got to have something in there that changes it. In our case, we're using the count variable. But maybe, I don't know, you'll have it if a certain key is held down, do this, and then as soon as the key is lifted, stop doing it. Something like that. There are various uses for it, but I find the for loop is more often the loop that I'll go to. Okay, the last concept we're going to look at in this video is functions, and there are 3 types of functions we're going to look at. We're going to look first of all at the inbuilt functions. So, let's talk about what a function is. A function is a block of code that has a name assigned to it that you can summon or call to do a particular task. And a function usually does one task, and it can take in some data and it can spit out some data, but it doesn't have to. It can just do a task without taking in or giving data, but usually it does one or the other or both. And the HISE comes with a bunch of built-in functions. We've actually already been using some. Console.print, for example, is a function. And we can also create our own. Now, when you see something in HISE script that is something dot something else, it's usually a function call, or unless you're accessing an object. So to find out all the functions that are built into HISE, click this button here that says API, and you'll get the API collection or API browser, and this lists all the functions that are in HISE. And you can do a search in here as well if you know sort of what function you're looking for. Like if you're looking for the function that affects buttons, you could type in button and then you get all the functions related to buttons. So yeah, that's all a function is. Another one we looked at was when we did the array.push function, and that's actually listed over here. And if you want to find out more information about one of these built-in functions, just right-click on it and it will give you some more information. You can also double-click it and it will insert it automatically for you into your script. Another way to pull up these built-in functions is if you kind of know what you're wanting. So if you're wanting something related to the engine, you can write engine and then dot and press the escape key, and it brings up autocomplete. And you can go down here with your cursor and say, oh, okay, I wanted the create MIDI list function, and you press enter and you get the create MIDI list. So those are the functions built into HISE. Now we're going to look at user functions. If you want something to do a particular task, it's probably best to put it into a function. And there are two types of functions that you can create. You're probably only going to use one of them. I think I only ever use one of them. But we declare a function by writing the word function. We give it a name, so I'm going to call it my function. Usually you give it a name that's related to what it does. Put some parentheses, and then put some... Oh, what's going on there? My function. Put some parentheses, and then some curly braces, and anything you write in these curly braces become part of the function. Depending on what your function does, you'll put loops in here, you'll put if statements, switch statements. You might even declare some variables. So there's all kinds of things you can do inside your function. Now usually if you're declaring variables in a function, you're going to use the local variable type because you just want it to exist within your function. Sometimes you might use a constant var. It depends on what you're doing. But let's just make a simple function that adds two values together and outputs the result to the console. So it's going to take, let's rename it actually, let's call it addition. And it's going to take two pieces of data, two numbers, and add them together. And the way we get numbers into our function is we pass them in these parentheses, and we call the things that we're passing in parameters. So we'll have A and B. So A is a parameter and B is a parameter. You'll also hear these referred to as arguments. So if you hear somebody talking about a function passing in arguments, that's the same as a parameter. So it's going to take A and B, and within here we're going to need another variable called C, and we're going to print C to the console. So this is the kind of stuff we've seen before. And what our function is going to do is it's going to do C is equal to A plus B. Actually, I'm going to change this to a var rather than a local. I'll explain why in just a minute. So that's our function. I'll hit F5. That compiles just fine. Now, when you use a function, it's called calling a function. So here we're calling the console.print function. We're calling the print function which belongs to the console object. So we're going to call our addition function, and all we do is we write addition, and then it needs the parameters passing in. Now these can be variables or you can just write the numbers. I'm just going to write the numbers. I'm going to do 50 plus 20. And then I'm going to hit F5, and when I hit F5 it's just going to run our function. And it'll output the result to the console. There we go, 70. Now you use a function when you want to do the same task multiple times, but you don't want to rewrite it multiple times. So now I can add all these separate sets of numbers together, but I've actually only had to write the logic of adding numbers once, and now I just call the function. So that's the advantage of functions, is you can do something multiple times but only have to actually write the hard part once. Now I changed that local C variable to a var, and I'll explain why. So let's just clear this back to our example there. If I change this to a local, we're actually going to get an error. Now hit F5, And it says cannot define local variables outside inline functions or callbacks. So this brings us on to the other type of function we're going to look at, which is inline function. So usually when you declare a function, behind the scenes when HISE script runs and it uses your function, it has to allocate a bit of memory every time you call this function. And that's not so good for real-time stuff, like if you're playing stuff on the keyboard and your on-note callback is calling functions, you might get audio dropouts if it's having to do memory allocation. So the solution to that is to use what's called an inline function, which doesn't actually call a function. All it does is, behind the scenes, it replaces all your calls to the function with the actual contents of the function. And you don't really need to worry about what it's doing. You just need to know that that's going to be more efficient for real-time stuff. And I will say 99% of the time you will use inline functions. In fact, I can't think of a time when I ever just use these normal functions now. There probably is some time, but I can't think of any. So to make an inline function, just write the word inline before function, and now it's going to be generally more efficient and you're not going to have as many problems, and you can use local variables. So if I hit compile now, it will compile just fine. So unless you come across a specific use case where an inline function won't work and you're advised by somebody on the HISE forum to use a normal function, I recommend you always use inline functions. Now, one other bit of advice when you're writing your functions is you may end up with your script containing several functions that you've written. You probably end up with like 10 or 20 functions you've written if it's a larger script. Try to avoid having a function that calls another function that you've defined. It's generally not a good idea to have one function dependent on another function. A function should do a single job. It should have a function that it does, and it doesn't rely on any other functions that you've defined. It can rely on built-in functions, that's fine, but don't have it relying on other functions you've defined, because if you change something in another function, that might mess up other parts of your script, and you want to try and avoid that. You want to have everything sort of encapsulated. So a function should do one job independently, generally. There will be cases where you'll need it to call another function, or you may write a wrapper function, which has the only purpose of calling other functions. That's kind of acceptable. But generally, just try and stick to one job per function. Right, one last thing we can look at with functions is a kind of special type of inline function, and it's a custom callback. So let's just delete this. So when we have, I'm going to add a button to the interface. So when we have a button and we want it to do a job, we can assign it to a module over here in the interface explorer, property editor, and we can get it to trigger modules and like bypass envelopes and effects and things like that. But if you want to script it to do something, you have to create a custom callback, and there are different ways to do it. But the simplest way is to right click on it over here in the component list and select create custom callback definition, which will put it on your clipboard and you can just paste it in. And this creates an inline function which has two parameters, component and value. And component refers to the control, in our case it's the button, and value refers to the value of the control, which is either 0 or 1 for a button, and if you had a knob it'll be a different range of values. And now in here you can react to the button press, so we can just put console.print value, and if I hit F5, I press the button, it's printing out 1 to the console, and if I press it again the button's off and it prints 0. So this is just a specific type of inline function. And then we have this line here which actually assigns the function to the button. So it gets the button using the getComponent function, and then it calls the setControlCallback function. Those are both built-in functions, and it assigns the callback function, which is our inline function here. So that's just one special type of inline function. There is another special use case of functions, which is paint routines, which is to do with vector graphics and panels. But I'm going to cover that in a separate video because it's quite a big topic. So for now, this is all we're really going to look at with functions. But it's important to know that you should use inline functions 99% of the time, and especially if it's going to be used in a real-time callback such as on Note or on Controller. Okay guys, that's all I've got for you for this video. That was the Quick Start HISE Scripting tutorial. Again, not really aimed for complete beginners, but for those of you with some scripting or programming experience, although I'm sure that there'll be some useful information in there for beginners as well. Thank you to my patrons on Patreon. Your support has contributed to the making of this video. If you're not supporting me on Patreon and you'd like to, you'll get early access to videos, you get some behind the scenes stuff and various unique things that I create just exclusively for my patrons. You can sign up at the link in the video description on YouTube. If you have any suggestions or comments or questions, just leave a comment below the video or send me a message on Patreon and I'll try and answer it. Thank you very much for watching, and I'll catch you next time.